Functional programming is skills. By the end of this episode, you will know what are the most important skills in functional programming. My name is Eric Normand, and I help people thrive with functional programming. So a lot of people ask, what is functional programming? There's a lot of answers out there. They're somewhat contradictory. Sometimes they're helpful, sometimes they're not. In the book I'm working on, the book's called Grokking Simplicity, which is out now if you want to go check it out. I have found it most useful to kind of bypass the definition, trying to define what functional programming is and say, well, that is functional programming, that isn't functional programming. Just bypass that whole thing and look at it as just a set of skills. And it's basically the skills that functional programmers do more often than other people do. Okay, so they're not incompatible with other paradigms, right? Object-oriented programming, you could also look at it like a set of skills, and so they're not incompatible. Object-oriented programming has, encapsulation and object-oriented modeling, and those are useful skills. And functional programming has different skills that you can mix and match and use them together with other paradigm skills. So what are those skills? I'm going to go over 5 main skills right now. So skill number 1. And I feel like this is an incontrovertible skill that you have to call yourself a functional programmer. This is just, it's non-negotiable. So you have to be able to discriminate between actions, calculations, and data. And I don't care what you call them. I'm calling them those for a lot of reasons. I have episodes talking about why I chose those terms. But actions, calculations, and data. You have to be able to look at your code and see, oh, that's an action, that's data, that's calculations. Okay? Calculations are computations from inputs to outputs. You might call them pure functions. Okay, this is pure calculations. Doesn't matter. When you run them, you're going to get the same answer if you give it the same arguments. Actions, on the other hand, can change depending on when you run them. Okay, you might call these impure functions. Okay, but they're not always functions, just like calculations aren't always functions in your language. Actions aren't always functions. Sometimes it's an operator, like an arithmetic operator. That's a calculation. Like plus is a calculation, but plus it's not a function. It's an operator. That is an action. Okay, so you have to be able to separate these out because calculations and data are very easy. They're much easier to work with. They're easier to test. They're easier to reuse because you don't worry about when they're getting run. But the actions, those are much harder. So in general, you want to have fewer lines of code in actions. You move those lines of code into calculations, and then you want to spend extra time on them to make sure that you get them right, because it really matters how you call them, when you call them, how many times you call them. Okay, so that's skill number 1, discriminate actions, calculations, and data. Skill number 2 is to be able to work effectively with immutable values. So we spend a lot of time in real-world information systems trying to keep records forever or for as long as we can. So we'll put papers, we'll file them away in a filing cabinet. We put some papers in like a fireproof box, and we use like archival quality paper and ink so that things don't decay over time, and we have rules about who's allowed to write on this paper, and like, oh no, this one is done, don't write on it anymore. Maybe you stamp it and you say this has been checked and vetted, it cannot be changed anymore. There's all sorts of real world mechanisms for making things immutable, making our records permanent. And when we're building computer software, often we are making an information system. But because of the way memory works, and memory is mutable, memory can change, we have kind of thrown that out, and we have to rebuild the skill of working with immutable data. We have to rebuild that as a discipline in somewhere, either in our programming team as our programming discipline that we implement, or maybe our language implements it, or maybe our database implements it. But we need to have it somewhere. And it's not the same as being able to just write over stuff and change it willy-nilly like you can with mutable data. And so a functional programmer has to learn how to deal with the immutable data. Basically, you're making a lot of copies. That's basically what it is. And I have a whole episode just on working with immutable values. One of the bigger challenges is working with nested data, because you want to change something deep in some nested structure. So you have a company has employees, and the employees have salaries, and you want to change, give everyone a 10% raise. So you're actually going through the company. It's an immutable value that represents the company. The employee is immutable, and the raise is immutable, or the salary is immutable. So how do you make a copy of that whole tree so that you can give everyone a raise? Or maybe you're just giving one employee a raise. What do you make copies of? So that is a skill that functional programmers develop. All right, let's move on. Skill number 3. So this is another important skill, and this is where the power of functional programming really starts to come out and shine. It's using and creating higher order calculations and actions. So I've kind of combined a whole bunch into one skill. I don't know why I did that, but it's really 4 things. It's using higher order calculations, using higher order actions, and then creating higher order calculations and creating higher order actions. But it fit well in one sentence, so let's call it one skill number 3. Higher order actions and calculations means they are actions and calculations that you can treat like any other value. So you can pass them to functions as arguments. You can return them from functions. You can store them in a variable, those kinds of things. And when they're higher order, it means that you can pass behavior to another function, or you can take, let's say, an action and automatically make it idempotent, right? Take an action and automatically make it retry 3 times if it fails, right? You can do stuff like that if you're operating at a higher order level. You can do it without it, except you're kind of writing a bespoke program to retry 3 times every time. By having it be higher order, you're able to manipulate it in a regular way so that you can have this behavior that is typically just boilerplate. You can have it just defined one place and it works properly everywhere. And this is where the power comes from of functional programming, where we have stuff like map, filter, and reduce. Those are higher order functions. They take functions, basically letting you build data transformation pipelines. This is where you get stuff like having sequences of actions that can retry and what happens when they fail, and you can define all of that compositionally instead of just a straight up, top-down code. This is very abstract stuff, so it's hard to explain. And as I'm speaking, I can tell I'm not getting this stuff through very easily. In structure and interpretation of computer programs, one of the first exercises, I think it's in chapter 1, is writing a function that takes a function and it returns a new function that calculates the derivative. So you pass in f as the argument, and it returns a function that is the derivative of f. And you don't know what f is. It could be any mathematical function. So, that's the kind of cool stuff that you can do in functional programming that it's kind of hard to do without those first-class functions. All right. Let's move on to skill number 4, data modeling. So we have these situations, these problems, these real-world processes that we are trying to automate. We're trying to solve with software instead of physical process. And how do we do that? How do we take measurements and other facts about the world, about things that are happening, combine those together into concrete structures in our code so that we can effectively use them, right? So data modeling is all about how do you structure the data that you have so that you can use it effectively. Now, I have an episode all about the 2 kinds of data modeling that we do. There's the data modeling where you're having a kind of a public-facing data that needs to maybe exit your library, exit your server. It's part of the API, and that data has different design constraints on it because it needs to be kind of human readable, because a developer on the other side is going to be writing that or writing a program to write that. So they have to understand it pretty well. And then there's the data modeling that's kind of internal, where let's say you're doing some kind of search through a space. Well, you need to represent the data in a certain way so that that search is efficient and it's going to, all the data you need is available, etc. So that's kind of an internal data modeling. And these 2 skills are very important in functional programming, but I kind of also think that they're more advanced. So I've been working up the chain here. I started skill 1 where you identify actions, calculations, and data. This is the beginning of functional programming, and data modeling is way near the end. Okay. So, number 5. Number 5 is architecture skills. Okay, you're building a system. You're building software, and you can't just throw all the code. I mean, if it's a little bit of code, you can just put it in one file. Architecture doesn't matter. But as it scales up, you don't want it to fall down. You don't want it to become unmanageable. So you need some kind of design principles, some kind of architectural principles, and functional programming has some, right? That are a little bit different from what you find in other paradigms. So one architectural pattern that comes from the functional programming world is the reactive reactive architecture. So I don't know if you're familiar with Redux in the React world, or the Elm architecture, or Reframe and ClojureScript. There's many of these, but the idea is events are being generated. You are consuming those events. That generates a view of the world, and then that view is projected out, say, onto a GUI. Right? So you have some state somewhere that is being modified, some centralized state. You modify that, and then from that it generates a projection onto a GUI. So So you have kind of a cycle going on. And it's all being done based on reactions, based on changes to the data. And it's an architectural pattern that you see in the React world quite a bit. Okay, another architectural pattern is the onion architecture. I've talked about this. There's episodes about it. The onion architecture is there are three main layers to this onion, and it's a sphere like an onion, where the outer layer is the interaction layer. This layer is where you put all your actions. This is the stuff that talks to the outside world, that gets messages from the outside world. And then that layer calls into the second layer, which is a calculation. It's a bunch of calculations, no actions in there. It is called the business rule layer. And that second layer, is where you have all the changing requirements of your business. How you calculate payroll, what's your vacation policy, like all this kind of stuff is in your business rule layer. And then inside that is the domain layer. This is the domain model. Okay, and there's just those three main layers, okay? You can break up each layer into more layers if you want, but the architectural pattern is just these three layers. And inside that domain layer is the kind of timeless domain model that the business rules call into. So, like I said, the business rules could be vacation policy and how you calculate salaries. But inside the domain model is the timeless idea that employees do get a salary, and it is some fixed amount. And employees do get certain amounts of vacation. How much vacation, that's a business rule. But they do get vacation is part of the domain model. Okay, so separating the things out into this onion architecture helps separate things out into basically a fast changing layer. That's where all your actions go, your interaction layer, because that's, you're connecting to this API. Oh, there's a version change for that API. Gotta modify the code to talk to this API, that API. That's changing very rapidly. The business rules change rapidly, but not as rapidly as that. Okay, this is the vacation policy change. We got to modify our code. But then inside that domain model is the stuff that changes least frequently. So the fact that employees get vacation is a pretty timeless thing, right? I mean, even if something weird happens and employees start getting zero vacation, that is at least modelable inside the domain model. And it's a weird case, right? Right now we're not giving vacation. Right now all of our salaries are at 0. It's still a number, like it still fits in the model. All right, so these are 5 skills that I am working on in my book. The book is called Grokking Simplicity. You can get an early access version now. If you're listening to this in my future, this is obviously my present, but in my future, it could be out, could be finished. Okay, so get it, buy the book. It's published at Manning. Just Google Grokking Simplicity, you'll find it. Okay, so here are the 5 skills. I'll go over them again. And there's more skills. I just have some big ones here. Discriminating actions, calculations, and data. Number 2, working with immutable values. Number 3, higher order calculations and actions. 4 is data modeling. And 5, functional architecture. If you like this episode, you should go to lispcast.com/podcast, and there you will find all the old episodes, including audio, video, and text transcripts of everything. You'll also find links to subscribe So you can get it in whatever format you want. And you'll also find links to find me on social media so we can talk. Just a warning, if you do reach out, ask me a question, or you have a comment, I might mention you in an upcoming episode. So if you don't want me to mention you, maybe you don't want me to use your name, or you don't like the question going public, just let me know that you don't want that, because otherwise I use this as like a public forum. So if you ask me a question, it's gonna be broadcast out. But just let me know, and I just won't use it. Cool. Thank you so much. This has been my thought on functional programming. My name is Eric Normand. Thank you for listening, and rock on.